Thank you very much. So I'm going to talk about the product portfolio we have at Cabot in inkjet and what we can bring, what our products can do for inkjet, and to make sure that inkjet has even a wider penetration into the market. So I'm technical service manager at Cabot, and before I start, I will just give a short overview of Cabot as a company. So we are 140 years old in operation, based in the US. We have more than 4,000 employees. Last year we had almost close to 4 billion revenues, 37 plant locations, so we are really have a worldwide footprint. Sustainability is very important for us, so we're really focused on that topic because we know it's important, and it's something we really are focused on. So we have two main business segments. So reinforcement material, where we are actually more focused on carbon black for rubber application. Performance chemicals, you will find there a wider range of application. Carbon black, few metal oxides, battery materials, conductive carbons, and of course inkjet colorants, which is the topic of the discussion today. As I mentioned, sustainability is very important for us. We are a platinum member. We got the platinum recognition for EcoVadis for the third year in a row. So this is really something we spent a lot of effort in to be there a leader in that area. If I now go a bit more into the inkjet business, we are not new to inkjet. We have been here for 25 years, even more than 25 years. Cabot, our expertise is in particle science. So we are really a particle company. We can produce particles. We can complex particles. We can design the structures. We can also modify the chemistry of these particles. And this is the link with inkjet, which is very natural because we are able to bring very different, we are able to bring a lot of chemistries and a lot of application which can be used in many applications. I would also say that we are very focused, so we are only producing water-based pigment dispersions. We do not make the ink, we do not make solvent or UV curable systems. We are really focused on water-based systems. This is really our core business. Maybe now a view on the market. So where we started, Cabot has really started into the office business. This is where we're coming from, so printing on paper especially. This is still, in our view, a growing business. We expect it to grow by about 20% per year. Next to that, we have more commercial application, graphics application, and sort of transactional direct mail and book. There as well, we also see some growth, about 15% globally. And I would say the big focus for us in the future, where we are really investing a lot, is water-based inkjet for corrugated packaging. This is really one area where we believe potential that we believe would be possible. It would be 10% penetration by 2030. A lot of discussion today on the fact that the penetration today is still very low. So there is a large potential ahead of us. Yes. The complexity of this inkjet application in different packaging, so you will see that, different substrates, different needs, different printing technology, printing heads, will translate into very different functional requirements from the customers. And some of these requirements you can see here. You need a highly stable dispersion and ink. You also need a lot of formulation flexibility. You want a pigment which will be compatible with a large range of chemistries. You also want to avoid settling. Of course, you need a good shelf life in your system. The nozzle health is extremely critical, so there is really a link there with the pigment technology and how the pigment is stabilized. We've seen yesterday some presentation about the cleaning of the printing heads. So the nozzle health is really crucial. You also need a robust system reliability. You minimize the downtime. A downtime, you're losing money if you have to clean your system, etc. Too frequently. It's an issue. And last but not least, the regulatory compliance is extremely important in packaging. You have food indirect or sometimes you have indirect food contact. So this is really something of importance, and this is where we are paying a lot of attention. Now, if we look in our portfolio, we have a unique portfolio in the sense that we are the only one on the market with two technologies which really enable a lot of possibilities in terms of formulation and performance in the ink. So what you will see here on the left-hand side is the surface modified dispersions, which was pioneered by Cabot. So we're actually bringing functional groups to the surface of the pigment to make it stable by electrostatic stabilization. And we've also, you can see on the right-hand side, you will also see encapsulated polymer dispersion, where we are actually bringing a polymer shell around the pigment to make it stable, and so that also it's compatible with a wide range of application. So I'm going to talk a bit now about the why of the encapsulated polymer dispersions. The most common way to make a pigment dispersion is actually to take a pigment powder. So you would buy the powder from a pigment supplier. You would mix it with the polymer dispersant. So you will first have a wetting step. You will go into milling to just break down the agglomerates of the pigment. Make sure you have a good absorption of the polymer onto the surface. And when this happens, in the end, you will have a pigment particle which is covered by your polymer dispersant. This works actually very well. The interaction there between the polymer and the pigments are done by van der Waals forces or hydrogen bonding, so it's really only physical interaction. It's really a physical process. There's no chemical reaction involved there in the process. If you do this at the dispersion level, so as I say, it's working quite well. However, when you start to formulate your ink in water-based ink especially, you will start to get issues. You will add your dispersion, stabilized with your polymer dispersant, to your ink. You will need a series of ingredients, humectants, other type of co-solvents, surfactants, binder, and these will also have, they will react, or they will also have interaction with your polymer dispersant. What will happen in many cases over time is you will get polymer desorption from the surface of your pigment. So the dispersant will actually be displaced. This is a reversible process. There is also a link with kinetics. So if you heat up, for example, there's a chance that this will happen faster. But the result in the end will be agglomeration. The pigment particles, they have similar surface chemistries. They will come back in contact with each other. And you will form agglomeration, worst case scenario, flocculation, sedimentation, so an ink you cannot use. So this is one of the main challenges with the classical mill-based dispersion. And this is why, for example, at Cabot we developed the encapsulated polymer dispersion, where the polymer dispersion and the pigment are actually mixed, but we also have an extra step, a chemical process, where you have a chemical reaction to make sure that the polymer is actually forming a core around your pigment, which cannot come off, so that even if you add different products, binders, surfactants, and so on, which may displace the polymer, because it's really locked in around the pigment, there's just no chance that you will lose stability of your system. And we see this as really important for water-based application, to have this type of technology, to really be able to have a lot of flexibility and tune your system for different conditions. This is the encapsulated polymer dispersion, and now I'll have a quick video about the surface-modified dispersion. So surface-modified dispersions, they are different, but also a bit similar in terms of concepts. We are also covalently, we also are bringing functional groups to the surface of the pigments, which are also covalently bonded. And this will also make sure that it cannot come off, so that you also have a wide range of compatibility with many ingredients. So this is again based on the know-how we have at Cabot, and on particle science, particle modification, and this also ensures that we have very strong colors in the print. So yeah, just as I mentioned, covalent attachment of functional groups to the pigment surface. And here we are it's more ionic repulsion, which is actually used to provide stability. We also are able to bring different type of functional groups. So this is something we can tune. Yeah, this is actually more the dispersants. This is it's what I mentioned with dispersant, which can come off and agglomerate. Okay, we provide supports and so on. We are well equipped. So as I said, we only make polymer dispersions. Well, sorry, we only make pigment dispersions, but we are of course assisting our customers in the design of the ink, working together to also find the best composition for our system. Yeah, the formulation flexibility again is very important. Here you would see that the surface tension is higher with our product or closer to that of water. Okay. Yeah. This is probably the most important slide I would say on my talk. We have a full portfolio of products, different technologies. And often the question I'm asked is, which dispersion should you choose, surface modified or encapsulated polymer dispersion? My answer would be there's not one size fits all. It would depend on a lot of things. What are you going to do, the type of substrate you are working with, the viscosity you're looking for, the choice of the ink, the binder, what type of co-solvent, the surfactants. Often also it comes down to the human factor, I would say, just the formulation preference. Often people are used to work with certain type of chemistry, certain type of binder, and they might work better with either encapsulated polymer dispersion or with the surface modified chemistries. I think it's quite clear that often people, when they have a project, they will use also the product they have in the lab for the new concepts, to what is already available on the bench. And this will also play a factor sometimes in just deciding which chemistries will be more useful or not. And I think with Cabot, this is the message here, we have you covered, because we can really find a solution which will be most compatible with your needs. So yeah, just on my last slides, we are committed to inkjet. We've been there a long time. We are now investing into a larger production, a 50 million investment in our inkjet facility in Haverhill in the US. We are focused on sustainability for packaging. We know this is important. This is something we are continuing to work on together with our partners. And yeah, we are collaborating also on key events. So you would see us in the next events this year if you want to talk with us as well. And yeah, here are my contact details. If you have any questions or if you want to talk further, I'm here today. But please feel free to reach to us for any questions or more information. Thank you very much.